Hi Year 12s, this is our last video talking about the cell membrane. So we've talked about what the structure of the cell membrane looks like, we've talked about how transport occurs across the cell membrane. Now we're looking at the factors that affect cellular transport. So we're looking at the different properties of the molecules and the cell itself that help determine how cell transport is going to occur. So starting with surface area to volume ratio, this is a really important one. So we know that cells need to produce their own chemical energy, which they do via metabolism reactions, in order to survive and keep up with Mrs. Gren. For all of that to happen, we need to be able to exchange materials with the environment. Now the rate of metabolism, so how fast those reactions are occurring, is all determined by the function of the mass and volume of the cell. So the larger a cell is, the more reactions are going to need to be occurring in order to support that cell's energy processes. Now, consequently, the amount of material exchange is dependent on surface area of the cell. So the more surface area a cell has, the more materials can cross in and out of the cell. As a cell grows, the volume increases much faster than the surface area does of the cell, which leads to a decreased surface area to volume ratio. So while you've got a larger volume and you need more reactions occurring, you're not getting an increase in the amount of materials coming in, which means that the metabolic rate exceeds the rate of exchange, and eventually the cell will die because of this. Hence, when a cell grows to a point that it's no longer efficient, it generally just divides and keeps itself in a smaller state to ensure it has a high surface area to volume rate. We can look at that a little bit more with this diagram here. So we've got one small cell here with, it's a cube, I know, with 1 centimeter cubed. We have 1 centimeter sides. We have another square over here, or cube over here, with 3 centimeter sides, and then we have one the same size of this. And I know the diagram looks a little bit confusing because it's been exploded up, but rather than having a 1 cube with 3 centimeter sides, we have 27 cubes, each with 1 centimeter sides, all put up together to increase the amount of surface area there. And we can look at how that changes. So in terms of surface area, we have a small surface area with our 1 centimeter cube with only a surface area of 6 centimeters squared. We have a more increased surface area with 45 centimeters squared with our cube with 3 centimeter sides. And then we have an even increased surface area with our 27 smaller cubes of 162 centimeters squared. Our volume obviously is quite small for our small cube with only 1 centimeter cubed. When we get to our 3 centimeter cube, we increase our volume to 27 centimeters cubed, which remains the same volume because it's the same amount of space inside for our 27 small cubes. So, where does that difference come along? Well, our small cube has a really high surface area to volume ratio of 6, which means we're having a lot of exchange of materials and we're able to keep the exchange rate higher than the metabolic rate. When we move to our larger cube of 3 centimeters sides, all of a sudden our surface area to volume ratio has decreased to 1.7, which means eventually if we continue to grow, our exchange rate is going to be less than our metabolic rate, which means the cell will eventually die. But if it's divided up into 27 small cubes, we see that our surface area to volume ratio rises back up to 6. So we've got the same amount of volume, the same amount of metabolic rate occurring as the larger cube, but we've got more surface area, so the exchange rate is being able to be increased. So this is better. Having 27 small cubes is much better than having this one large cube. And that's how surface area to volume ratio works. But it's not just the cell itself that determines what type of transport is going to occur. For example, we need to talk about the type of transports that happen based on chemical properties and physical properties. So physical properties that we look at the molecule include size and charge of a molecule. So we could be talking about large and small, or ions. We don't talk much about ions here, but know that ions are basically, ions determine what type of transport will occur. Chemical properties, we need to talk about things like hydrophobic or hydrophilic. So a small hydrophobic molecule will move via diffusion, because it can just cross the cell membrane through the hydrophobic natures. Whereas a large hydrophobic molecule will need to go through endo or exocytosis because it's too large to physically just move through those fluid membranes. Whereas a small hydrophilic molecule will need to go through facilitated diffusion because a hydrophilic molecule can't move through the hydrophobic properties of the cell membrane, or the lipid tails. Even though it's small enough to just diffuse through, it can't because of that hydrophilic nature of the molecule. Whereas a large hydrophilic molecule has to go through endo or exocytosis again.